Lesson 1.3. Today we're talking about the midpoint of a line segment. And the midpoint is just the spot that marks the exact middle of the line segment. So what that means is if we've got T here is the midpoint of line segment SU, then T right here in the middle splits these two things up into two equal parts. So ST is going to equal TU. So we can set these two measurements equal, okay, because that's the exact middle, the midpoint, middle. So point in the middle. So what we're going to do is say 8x plus 11 equals 12x minus 1. So solving this using algebra, I'm going to combine like terms. Okay, so my 1's cancel, the 8x's cancel, 11 plus 1 is 12, and then this should be 4x. Then when I divide both sides by 4, I end up with x equals 3. So in the problem up here, if we look back at this, it does say just to find x. We don't have to go back and find the other measurement. So we are good there. Now for number 3. If R is the midpoint of QS, line segment QS, find what the measurement is. And I probably should put congruent up here, by the way, because we talked about congruent the other day. The measurements don't have the line up at the top, and those are equal, but the lines being congruent, we would say, has that line above the representation for what we have for the line segment. So again, I've got R is the midpoint, but this time we want to find what is QS as a whole. Okay, so again, these two sides are equal to each other because we split the line into two equal parts. Okay, so combine like terms. I'm adding x to both sides. And I'm going to add 3 to both sides. So my x's cancel, my 3's cancel, and I end up with 6x equals 24. Then when I divide by 6, x equals 4. So since we're asked to find what QS is, I'm going to take the 4 and plug it in to one of these equations up above. So if I take 21 minus x and I put 4 in for x, it'd be 21 minus 4. So then I have 17 as that one side. But we know that the two sides are equal. So this is also 17. So QS is going to equal 34. Okay, now let's look down at, okay, let's try number 5. If line segment EF bisects CD, line segment CD, then CG is going to be 5x minus 1. GD is 7x minus 13. And then the segment EF is 6x minus 4. So that's this whole thing right here. And then GF itself is 13. So we need to find EG. Okay, so we've got a term up here, bisects. Bi means 2, so it splits it into 2 equal segments. So we can say that 5x minus 1, which is CG, is equal to 7x minus 13. So combining like charms here. I've got 12 equals 2x. Divide both sides by 2. And x is going to be 6. Now, they didn't ask us to find what x is. They asked us to find what CG is. And so this whole thing over here, okay, we had 6x minus 4 is the entirety of EF. So let's see what EF is going to be. So we've got 36 minus 4, which is 32. And then this section right here, GF, is 13. So using the segment addition postulate, we know that EG and GF added together equal the entire thing. Well, this is the whole thing right here. So we're going to subtract this 13, which is the part. And then we'll get the other part, which is what we're asked for, EG. So 19 is what we have for that.